Now let's go to the second question. When you have f of x equals e to the negative x power over x, show that the derivative equals this. We know show that, which means basically they ask you what is the derivative of f of x. Therefore, for f prime of x equals, using the quotient rule is you have u over v, derivative equals v squared, vu prime minus v prime u. So you will get this x squared. Then bring this x to the top. Then we do the e to the negative x, we do the derivative. Then minus here, this is a minus. You will get x to the derivative, then e to the negative x power stay. So we organize x squared, the x times e to the negative x power itself, then do the chain rule. Derivative for negative x will be negative 1. Then minus 1 times e to the negative x power equals, here's the x squared. Check the form given. You have to take e to the negative x power outside. Therefore, let's organize first, then we take e to the negative x power outside, do the factor. So we have negative x e to the negative x minus e to the negative x. This time, I will take a negative e to the negative x power outside. You will get the positive x, then plus 1 over x squared. This is the way to do the show that work in IB exam. Now let's go to B. Find the interval where the function is increasing or decreasing. From the original function, you could say the domain has to be the x not equal to 0, because you cannot make the denominator equal to 0. And just check over here, this derivative function. We know that is x squared has always a positive. Any e to the negative x power has to be positive, but negative e to the negative x power, it will be negative. We know that for any y equals b to the x power, the exponential function, b to the x power always greater than 0. No matter for this x is all real numbers. The range is always greater than 0. Therefore, we can write down this, greater than 0. But you have negative sign, so therefore, this will be less than 0. Let's go back for x squared. This will be always positive. And for this part, it will be negative. Then we need to check here, x plus 1. When x plus 1 greater than 0, you could say the f prime of x will be less than 0. So you solve x plus 1 greater than 0. Then you will get the x greater than negative 1. So that you could say this graph is decreasing. But remember, the x is cannot be 0. So you can write down the interval way that will be the from negative 1 to 0. Then union set from 0 to infinity. In this interval, the function is decreasing. Then on the contrary, when x plus 1 is less than 0, which means the x less than -1, you could say the derivative is negative, negative, positive, it will be positive. So the function is increasing. If your question didn't say hence, then you just need to go to graphing calculator like y1 equals e to the negative x over x. You graph, you can get the interval. When they say hence, that means they expect you to use the first derivative to get the interval for increasing or decreasing function. For say, classify all the stationary points. We will set up the f prime of x equal to 0, which means negative e to the negative x power x plus 1 over x squared equal to 0. For a rational function, if I have a over b equal to 0, which means we will set up a equal to 0 to solve the roots of this rational function. So we need to make the top equal to 0, negative e to the negative x power x plus 1 equal to 0. We know that e to the negative x power never equal to 0 because e to the negative x power is always greater than 0. Therefore, we need to figure out it's just x plus 1 equal to 0. So your x equals -1. The y equals, we put into the original function, that will be e to the -1 over -1. So you will get e to the first power over -1, that is a negative e. So basically, the stationary points you will get is a -1 and a negative e. So classify this point is maximum or minimum. Then all stationary inflection point you need to do is this. We will create a table. So you have x, f prime of x. Then here I have -1, -1 plus 0.1, -1 minus 0.1. I have here's a 0. You need to put this number into the function like this, the derivative function here. Then you could say this will be positive, here's a negative. Therefore, this is increasing, this is a decreasing. You could see this point will be a local maximum point. Let's go to the last question. Show that y equals this has a local maximum when x equals pi over 4. So first of all, you need to get the derivative dy by dx. We got to use the product rule. 4 is a coefficient, so we do the e to the negative x power, we do the derivative, then times sine x, plus e to the negative x power then sine x, we do the derivative. So we organize, you will get the e to the negative x power times the -1 by chain rule, sine x, then plus e to the negative x. Derivative for sine x will be cosine x. Therefore, you will get the 4. We take e to the negative x power outside. You will get the negative sine x plus cosine x. We organize 4 times e to the negative x power. Then we do the cosine x minus sine x. since we are looking for the local maximum, right? And we need to make a derivative equal to 0. So dy by dx, we set up equal to 0. We need to solve for x, that is for stationary points. So you get the 4e to the negative x power. Cosine x minus sine x equal to 0. We do know that e to the negative x power never be 0. So you will get the cosine x minus sine x equal to 0. So we cross, you will get the cosine x equals sine x. In what angle the sine x equals cosine x, we know the x equals pi over 4. Or if you want to show like this, it will be fine. Cosine x equals sine x. So you divide it by cosine x both sides. Then you can get tangent x equals 1. Then you can get the x equals pi over 4. Then for third one, we need to test using the neighbor value test. You have here's x and here's f prime of x. So this is a pi over 4. Pi over 4 plus 0.1. Then pi over 4, you minus 0.1. This part is 0. The derivative function, that is 4e to the negative x power, cosine x minus sine x. When you substitute pi over 4 minus 0.1 into this derivative function, it's a positive. Here it's a negative. You could say it's increasing, then go to the pi over 4, then going down. So it is a local maximum at x equals pi over 4.